Hello everyone, I'm Yash and this is the third experiment for ECE 505, that is Intro to Embedded Systems. And in this, we'll be using the UART protocol. We'll be coding the TM4C123GXL Launchpad on the UART protocol, and we'll be printing the results as well as getting the inputs from the terminal. And this is the terminal. As you can see, I am using CoolTerm as the terminal, and this will be connected with the uh, port with which I have connected my TM4C with my laptop. And as you can see, um, yeah. So as you can see, the baud rate is set to 9600. The parity bit is none. So stop bit is 1 stop bit and data bits are 8. And in this, we have used Stellaris virtual series port, that is the TM4C that is connected to the COM3 of my laptop. So, and giving a brief introduction about the experiment, this is main C. This is I have included main.c. In this, there are multiple header files as well as .c files as well, as far as I know. No, so we have included the .h files. This is the led.h that will be enabling the pins and GPIO port for the green LED to toggle on and off. Then in this, we have a toggle green to toggle the LED to switch on or off whenever there is a character sent to the terminal, which was the CoolTerm. And the setup includes the enables the port F of the GPIO port F, and we have also included UART stdio.c, simple underscore UART.h, simple underscore UART.c. I am briefly giving an introduction about this. So in this, we have first enabled the GPIO port A where the UART pins are, then enabling port A and port A0 and A1 pins as well. And then in the end, towards the end, what we have done is like set the baud rate at which the data will be transferred. So it is 9600, and that's the same baud rate that I have used on my terminal as well to not to minimize the loss of data. And main.c, this includes multiple libraries. Also, we have included in the same project, we have also included driver.lib, driverlib.lib. This is the library from TIVA series itself. And in this project, I've also included the variable path where the TIVA series C series 2.2.0.295 package lies. And in this, we have in main, we have I have added char c this char, which enables, which is a character called char c this char. This will be helpful in getting the value from the terminal using a function UART char get UART 0 base. And after that, we have computed, used the internal thermometer or thermostat, whatever you guys want to call it, to get the temperature of to get the temperature of the environment using the Launchpad. So this is the temperature meter for the Launchpad itself. And then we have converted it to Fahrenheit scale as well. Earlier it was in Celsius scale. And then if I input the F character here, in the terminal. This is for the terminal. If I get the character F for the terminal, so UART char get gets the character till waits for a character till a character is pressed. And there's an if-else-if construct here. If the char is F, inputted character is F, then it will print the Fahrenheit scale. If it is C, it is the Celsius scale, and if it is G, yeah. So if the character is get is F, it will print the Fahrenheit equivalent of the temperature reading. If the character which the terminal which we type on the terminal or the user type on the terminal is C, the the output will be in Celsius, and if the character which we get is which the UART receiver gets is G. So the green LED on the TM4C will toggle on or off. If it is on, it will toggle off, and if it is off, then it will toggle on. So that's how it goes. And if we press enter, then the code will exit. So this is basic of what the code is all about. And here is the print temps function, and here is the convert to Fahrenheit function, in which we have converted the Celsius reading of the temperature to Fahrenheit. And in print temps, I have changed I have printed the temperatures or the Celsius equivalent of temperature and the Fahrenheit equivalent of temperature onto the terminal itself. So let's see how it goes. So I have built the project. Now I'll be debugging it. Yeah, so you can see that there's no LED which is turned on, and as the language is case sensitive in nature, so we need to consider if we are putting the small c character for Celsius or the capital C. So we have to put all the capitals as the code. In the code we have implemented the capital characters. So I'm connecting it to the Stellaris virtual series port. That is my Launchpad, and there's nothing else that will be printing on the screen. It's because we haven't input the character, and the UART char get is waiting for the user to get a character. So I have turned the caps lock on my keyboard on my laptop. So now I'll be hitting the C key, and as soon as I hit the C key, oh, I haven't, yeah. So yeah, so now it goes. Actually, I haven't removed the previous run that I did, so that's why it's showing that, but it should have just shown this instead, the thing that I have highlighted. Yeah, so I am printing using C. So the user input equal to C, temperature equals to 21 Fahrenheit, 21 Celsius. And the Fahrenheit temperature will be when I press F, the user input is F, print temperature is 69 F, and if I hit G, so it toggles on. If I hit G again, it toggles off. So this is the code. And if I'll blow warm winds to increase the temperature of the TM4C, you can see that Celsius will be increasing. Right now it's at 21. Now it says 23. So that's how the experiment is performed. And I'll be clearing the data, disconnecting this, switching off the terminal. I'm not saving it. And this was the experiment 3 using the UART protocol.